Hi, in this video we're going to look at compound interest. We've previously looked at simple interest. Simple interest and compound interest have some similarities but also some significant differences. Here's a link for a YouTube video to help explain that, and this link is also available on eLearn. Now with simple interest, the interest is calculated on the initial balance known as the principal. This means that the dollar value of interest added during each period remains the same. We have our simple interest formula where the interest calculated by the principal multiplied by the rate as a decimal multiplied by the number of periods, usually years. And to find the final amount, you just add your starting amount plus any interest that's been earned. This results in a straight line graph, a linear graph, because the value of the increase remains consistent during the period of the investment alone. With compound interest, the interest is calculated on the balance at the end of each compounding period. This means that the dollar value of the interest added during each period is calculated on the principal and the amount of interest that's been previously added. This means that the value of the interest is increasing with each compounding period. And by compounding period, you mean the time that each period when the interest is added on. Now you could do this, so it's increasing with each compounding period compared to the straight line graph we had with simple interest, because the interest that's added on here is calculated on the balance of the previous term and so forth. Now you could do repeated calculations to find that amount of interest, but if, for example, it was compounding monthly for 12 years, that would mean you'd have to do 120 calculations. So we have a compound interest formula. Now you can see that the components are the same as with the simple interest formula, but there's some significant differences. First, the most one is the rate. It's not only written as a decimal, but it needs to be per compounding period. And N is the number of compounding periods in total. So let's have a look at how this compounding formula works. In this example, we've invested $12,000 in an account at 5.4% per annum, means per year, and it's compounding annually for 5 years. What's the final balance? Step 1, we organise our information. We want to find our final balance. The principal is $12,000. Our rate as a decimal is 0.054 per compounding period. It's compounding annually. And N is 5 because it's compounding once a year for 5 years. We substitute into our, write down our formula, substitute into our formula, calculate our answer, adding our units, check that we've answered the question, and check that the answer seems reasonable. Now in this example, it's important to know that the interest is compounded annually, so the number of compounding periods each year is 1. That's important. Let's have a look why in this next example. Here we've got $8,000 invested in an account at 6.3% per annum, and it's compounding monthly. This is a significant difference for 4 years. What is the final balance? So step 1 is same again, organise our information. Our final balance is what we're asked to find. The principal is $8,000. Now in this example, we said the interest is compounded monthly, so the number of compounding periods per year is 12. Our I is our rate as a decimal per compounding period. So if our interest is 6.3% per annum, that's 0.063 as a decimal, we need to get it per month, so we're going to divide it by 12. Now our N value is the number of compounding periods. So it is compounded for 4 years, but 12 times a year, so there's 48 compounding periods. Step 2, write our rule. Step 3, substitute our values into the rule. Step 4, calculate our answer. Step 5, include our units. check that we've answered the question, and see if our answer is reasonable. So our $8,000 grew to $10,286. That is a reasonable answer. So remember, you need to consider how often it's compounding. In this case, it was monthly, so there was 12 compounding periods per year. Let's have a look at another example. In this example, we've got $14,000, 4.8% per annum, and compounding quarterly. Now, as soon as you see this word compounding, you know you're going to be using our compound interest formula for 7 years. So it's compounding quarterly, which means the number of compounding periods each year is 4. Step 1, organise our information. Our final balance is what we're asked to find. The principal is $14,000. Our rate is 4.8% per year, so that's 0.048, but we need to get it per quarter, so that divide it by 4. And it's 7 years, but it's occurring 4 times a year, so the number of compounding periods is 28. So our final value, we write down our rule, substitute our values in, step 3, calculate, step 4, add in our units, and check that we've answered the question, and check that our answer is reasonable. So remember, in this case, the interest rate needs to be divided by 4 to get it to a rate per quarter, and the number of periods is the number of years multiplied by 4. So remember, our 5 steps are: organise the information, and for compound interest, pay extra attention to the I and the N values. Write down your rule, substitute your values, calculate, include any units, and check if your answer is reasonable and you have answered the question. So here's some questions you can practice on. Thank you.